Welcome back, everyone. My name is Alex Wiseman. We're still talking about theory testing and theory building. This is the second screencast in a series of 3. In the first screencast, we looked at what is theory. We looked at some of the benefits of theory. We looked at limitations, and we looked at the elements of theory. So you should have a big old theory headache right now if you've been following along. We're specifically talking about social science theory, and I'm specifically thinking about comparative and international education research and theory that's relevant to that, although we haven't named any specific theories in that way. In this video, we're going to talk a little bit more about theory testing and what the point of that is. In some of my classes that I'm teaching, we're talking about theory specifically related to comparative and international ed. But we're struggling with the idea of how do we really think about them in terms of what do we do to test a theory to find out if it is a fit for a particular phenomenon or not. And then how do we build theory if we need to develop a theory in order to help us understand a particular phenomenon, how do we go about that? So for the next 15 minutes we're going to be talking more about theory testing than anything else. So pardon me while I zoom past, there we go, to our theory testing section. I should also say right off the bat, please don't forget that I am borrowing pretty much everything here from these two references, the Kolkut and Zapata-Phelan article out of the Academy of Management Journal and the Bhattacharjee online textbook from the scholarcommons.ucf.edu site you see linked here below. So please do assume everything good that I'm talking about comes from one of these two references. Everything that you disagree with or don't like is my spin on it. All right? So let's start by talking about what theory testing is. And very simply, let's just walk through this explanation. So, theory testing is, as the name suggests, the process of testing whether a certain theory of your choosing, pick one, is a plausible explanation of a phenomenon that you would like to investigate. So, as a comparative and international education researcher, I am interested in comparative education phenomena, and I'm interested in comparing how particular phenomena occur in different national education systems. That's my own interest, right? So I try to choose theories that will help explain that kind of cross-system or cross-cultural educational phenomenon. Okay, so how do I test that? Well, put simply, the main focus of theory testing is to discover whether there is evidence, that is key, that either supports or does not support a particular theory. Remember, the point of theory testing really has two prongs. One is you're using evidence, empirical data of some sort, observable information, right? So you're using evidence, and then you're using that evidence to either say, this theory does seem to fit as an explanation for that phenomenon. Or to say, this theory does not seem to fit for this particular phenomenon that I'm looking at. All right? So you don't have to find a fit. That's not the point of theory testing, to find a fit every time. The point of theory testing is more to use data to test whether or not it does or doesn't fit, or it does or doesn't support the phenomenon. All right, that's important. It is crucial that you understand the theory as it is used or explained, rather than superficially reducing it to only the points that you agree or disagree with. So theory testing doesn't have to do with popularity of a theory, or whether or not you like a theory. Theory testing has to do with whether or not there is evidence that either supports or does not support that particular theory for the particular phenomenon you're trying to explain. Right? Don't reduce it. Don't be reductionist about it and only put it in terms of, well, I think this is a theory that pushes a particular agenda, or I think this is a theory that is only used by these types of people. Right? Those would be reducing it to points that you agree or disagree with. Don't do that. Use the data to test it. So the point is, you have to not just know whether you like it or don't like it, or agree or disagree with it. You have to deeply understand a theory in order to test it. And you have to deeply understand how it is used to frame empirical research before you can adequately test it. In other words, look at the ways that those who are considered experts in a particular theoretical field or frame are using data to test the theory. Understand how that empirical research is testing that theory, or how that theory is framing the empirical research. Get familiar with that. Then you can start to test it. Okay, so that is what theory testing is in sort of a nutshell. So how do we test a theory? Well, there are 4 ways that we can think about whether or not a theory fits a particular phenomenon or is an adequate framework for explaining a particular phenomenon. The first of those is logical consistency, which basically asks us, are the theoretical constructs, propositions, and boundary conditions and assumptions logically consistent with each other? In other words, do they all fit together, the constructs, the propositions, and the boundary conditions? Remember, logic was one of the elements of a theory. So this is saying, can we use logic to bring together the other 3 elements? We know that if some of these building blocks of a theory are inconsistent with each other, then the theory is not a very good one. In other words, it's not probably going to be supported by the data. For example, if a theory assumes some sort of rational behavior, but the constructs represent non-rational behavior or non-rational concepts, then that's a logical inconsistency, where rationality is assumed, but non-rationality is actually what we see. Then we're going to have a problem with this working. We're going to have a problem with this actually being an accurate and appropriate way of framing our research. So logical consistency. Do the constructs, propositions, and boundary conditions remain consistent with one another? Another way to test a theory, hopefully using data, is through explanatory power. So how much does a given theory explain or predict reality? Good theories obviously are going to explain whatever your target phenomenon is better than rival theories. Now, if we're more quantitative, we can measure that sometimes by something called R-squared, which is a measure of fit or variance. You often see it in regression equations. If you are a more qualitative person or using more qualitative approach and you're trying to think about whether or not your theory fits your target phenomenon, then you're going to be looking at whether or not there is you might be looking back at that logical consistency. Is there explanatory power when you fit all these components of a theory together for your qualitative situation? So explanatory power is another way to test a theory. How much does a given theory explain or predict reality? By the way, this is probably the most common way to test a theory because it's the way that you can use data the most obviously. Right? If you have data of some sort that you're using, either qualitative or quantitative, to test a theory, you're looking at whether or not the theory explains what the data shows, because the data is what you have to represent reality. So how much does the theory explain what the data shows? A third way to test a theory is to see if it's falsifiable or if it has falsifiability. In other words, is that theory potentially disprovable? And what's important about this is falsifiability ensures that the theory is potentially disprovable because if empirical data does not match with the theoretical propositions, then that allows for empirical testing by researchers. That's going to be important in order to avoid what we call tautological statements or tautologies. For example, a tautological statement could be, a day with high temperatures is a hot day. But you can't empirically test that because a hot day is defined and measured as a day with high temperatures. You see how that's a big old circle. It just feeds back on itself and it becomes this loop. You don't have any way to test it because it all depends on the other parts. Or you could say a school with high test scores is a good school. Well, that probably isn't empirically testable because good schools are often defined and measured as schools with high test scores, unfortunately. So we're left with some issues when it comes to tautologies or tautological statements, and we want to avoid that. So we have to have rival explanations. And some of you who are in the doctoral seminar that I'm teaching right now, you might recognize this as something that I'm asking you to do when I'm asking you to do your assignments for class. I'm asking you to look at a particular set of theories called world theories, and then I'm asking you to provide an alternative theory or a rival theory to explain whatever phenomenon it is that you are looking at. This is a way of getting at falsifiability, right? Either of that world theory or of your own theory. You're just trying to provide an opportunity that the theory is potentially disprovable, whichever theory it is. And one of the ways that you can see if a rival theory has a better fit or is a better explanation is through this explanatory power test. Okay. Last is parsimony. In other words, how simple is the explanation? I mentioned this in the first screencast when we were talking about some of the characteristics of theories. And it's basically the fact that the simplest theory is the best theory. In other words, the theory that uses the smallest number of variables or makes the fewest assumptions. Sorry about the misspelling there. That should be an S, and that's a U. The theory that has the smallest number of variables and makes the fewest assumptions is the best. The fewest assumptions is, quite frankly, the bigger part of that. You can have a larger number of variables if you're not making a lot of assumptions about the conditions or the situation or whatever, and that's going to be a much stronger theory than one that has fewer number of variables but makes a lot of assumptions along the way. So there's sort of a sliding scale between number of variables and number of assumptions. If we have variables on one end and assumptions on the other end, I think you'd want to be, well, in the middle would be ideal, but probably this direction is better than making more assumptions. Okay, so how to test a theory? You look for logical consistency, you look for explanatory power, you look for falsifiability, and you look for parsimony. Now, that Colquitt and Zapata-Phelan article that I mentioned right at the beginning provides us with a way of estimating the degrees of theory testing. The degrees of theory testing are from a taxonomy of theoretical contributions for empirical articles, which I've provided a copy of here. If you find and download that article, or you already have it in front of you, you can look for this figure in there as well. It's simply a way of looking at the overlap between building and testing theory, and I think that the authors were suggesting that what's really good is to be in this expanders category, to be doing both theory building and theory testing. I'm looking at the x-axis, and so you'll see that there's a 1, a 2, a 3, a 4, and a 5 down here, and same here, 1, 2, 3, 4, 5. So at the lowest degree of theory testing would be that we see that there is inductive, or that the theory is inductive or grounds predictions with logical speculation, right? So it's inductive or grounds predictions with logic. That's going to be the basic part of theory testing. If we're testing a theory and we want to see that somebody is testing a theory, they're making predictions using logic. At the second stage, or the second degree, would be grounding predictions with references to past findings. So now we're actually using whatever theory that we're talking about and looking back at what has been done before. A third degree would be grounding predictions with existing conceptual arguments. So actually taking some existing arguments and using them as part of that logic. Then grounding predictions with existing models, diagrams, or figures, and finally with existing theory. So if you can ground your predictions with the existing theory and then you can test that theory using data, you are theory testing. Congratulations. So think about these as you're thinking about how to test a theory. Apply them for those of you who are in class with me when you're trying to put your assignments together. And now let's move on to our next screencast about theory building.